All right, I want to welcome all of you to this PolarConnect event. Thank you for joining on such short notice, but we're really excited to have Yamini Bala and the team that's part of the Velvet Ice West Antarctica Ice Sheet Microstructure PolarTREC expedition. It's a mouthful, but it's a very exciting project. Today is December 11th, 2014 in North America. For those of you that might not be familiar with Antarctica, it's actually a day ahead, so it's December 12th down there. And like I said, we're really excited to have this PolarConnect event with this team. A few things before we get started that I need to share with you. We are using a platform called Blackboard Collaborate, and the slides should have changed, and you should see that there's a little diagram about Blackboard Collaborate and some of the features that we will be using. If you have any trouble as we go along, please type it in the chat room, and Sarah and myself, who are moderating this PolarConnect event, will help you go through the things. Oh, it looks like the Velvet Ice team is joining, so let me see what Sarah and them have going on here. We might hear a phone in a moment. Yep. Conference. I'm going to pause.
You will now be joined to your conference.
Okay, so yes, so mute your phone, Yamini.
So this is Janet, and can everybody in computer land hear me? Just type in a chat room if you can hear me. Okay, excellent. So we have Yamini has joined, and as I was saying, the slides should be showing up in the middle. If you want to talk, when we have time for questions, we ask you to click on the talk button once to open your mic and unclick it when you're done. And there's also a feature where you can raise your hand, so if you have questions as we go along, click on the little hand icon above the list of participants, and that lets us know that you have a question. And of course, you can use the chat area to type in questions or give us any feedback. And we also want to welcome, it looks like Tom Harton and maybe some of people with him. Okay, the next, whoops, sorry, skipped one. So as I go through these slides, I would like you to introduce yourself. So in the chat box, type in your school and the number of people that are with you, or students or adults, and then we can kind of keep track of who's joining us. And Yamini is online, so she can also see that today. A little bit of background about what is PolarTREC. So it's a program, teachers and researchers exploring and collaborating. We're funded by the National Science Foundation. And our job is to place teachers with scientists so that they can get experience in science and go back to the classroom and be better at teaching science. And we put teachers throughout the polar regions, both the Arctic and the Antarctic. And right now is our Antarctic season, and we have like 3 or 4 teachers that are down there already, and another one that's headed out in the next couple months. We have another PolarConnect event tomorrow from another teacher that's in Antarctica, so if you want some more of it, please join us for that PolarConnect event as well. Again, a little thing about questions. If you have a question during the presentation, type them in the chat box. You can always raise your hand. It's a smaller group, so we can probably interrupt and get to your question right away. We will also have time at the end of the presentation for questions. This event will be archived, and so if you have to leave early today, we'll post it on the website in a day or two, and you can review the archive. And I think that's it. I'm going to turn this over to Yamini, and let's see how she's doing and if we can hear you. So Yamini, go ahead. Sarah, do we still have Yamini on the phone?
Can you? I just saw. Oh, yep. Go ahead.
Okay, I think our microphone is a little weak, so I'm going to talk over the phone.
It sounds great. Thanks, Yamini.
Okay. And all right, there's a pretty big delay, so we will try our best on the phone. Yes. Hi, everybody. Sorry for the confusion. But it's really nice to be here and see you guys. We are the Velvet Ice team, and just so you know, my name is Yamini. I am a PolarTREC teacher, and we're here with Erin Pettit, who is our principal investigator. That basically means that she leads our scientific research. Also on the Velvet Ice team, we have Rachel Aubert, who is the co-principal investigator, meaning that she also leads our research. And we have Tiffany Green, who is an undergraduate student at the University of Alaska at Fairbanks. And we're all here today. We're all excited to talk to you guys. Hi. Hi. Okay, so we are working in Antarctica as scientists. Hopefully you are on the slide that shows us just getting down, just touching down at McMurdo. We arrived a week ago, and there's a picture of us right in front of the New Zealand Air Force plane that brought us here. The next slide, Antarctica is a big place. So there's a picture here where you can see a map of the United States, which is superimposed on top of Antarctica. And you can see that Antarctica is almost twice as big as the U.S.
And Yamini, I'm going to interrupt just real quick.
Okay.
Did someone else just join by phone?
Hi, my name is Siva. Hi, my name is Siva Patli. I'm calling from California, in front of Yamini.
Great. Thanks for joining us. And if you're joined by phone, if you can mute your phone or press *6, and then Yamini will keep talking. Thanks for joining.
Thanks.
Okay, go ahead, Yamini.
Okay. So we are on a slide that says, where are we? And right now, so you can see that whole image of Antarctica, and we are currently at McMurdo Station. That's the one on the bottom, kind of in the center. There's a red dot. And next week, as soon as the weather is good and as soon as our flight takes off, we will be moving to WAIS Divide. And you guys will be hearing a little more about WAIS Divide in a few minutes. So moving along, the next slide shows that Antarctica is the highest, the driest, and the coldest place in the world. So you can see from the pictures that there's a lot of wind blowing the snow around, that you can see snow and ice pretty much everywhere. So on the next slide it says Antarctica is the highest continent because there can be up to even more than 2 miles of snow piled on top of the land in most places. The picture that you're looking at is a picture of one of the glaciers, and it's the end of a glacier, so you can kind of see how tall it is. And just for a black dot in the middle of the glacier, that's actually a person. Actually, it's Erin, our scientist, who is climbing up the face of the glacier. So that just gives you an idea of how
Yeah,
on the next slide you can see, yeah.
Hold on a moment. I don't know if it's your background or if it's somebody that's by phone, but we need to make sure everybody's muted your phone, but we're getting a wafting sound and it breaks you up. It could be it could be the connection from McMurdo. So Just everybody double check your phone, *6 to mute, or press the mute button. Make sure your computers, if you're using both, are muted, and we'll see how it goes here, Yamini. It might be you. Okay, go ahead.
Okay. Okay. So we're on a slide that says Antarctica is the driest continent because it's actually one big desert. A lot of people don't realize this because they see so much snow and ice. They think that it's a place where it's constantly snowing, but that's not really the case. I think on average, Antarctica meets the criteria of being a desert because it receives less than 10 centimeters of rain or snow every year. And there are some places that get a lot more than this, and there are some places that get a lot less. So the picture that you're looking at is a place called the Dry Valleys. It's a small part of Antarctica where it actually hasn't rained in over 2 million years. So you won't see snow or ice or anything there, but it's very cold and it's very dry. In the next slide you can see that the reason Antarctica can have 2 or 3 miles of ice and snow piled on top of it, even though it's not snowing very much every year, is because it's so cold that the little bit of snow that we do get here doesn't melt every year. So for us in Chicago, for example, we'll get maybe more than 10 centimeters of snow a year, but every summer when the sun comes out, it will melt and go away. In Antarctica, it doesn't melt because it stays so cold. So it's not uncommon for the temperature to go below -100, but there are only a few places and very rarely where it goes above 40 degrees Fahrenheit. So you can see from the look on the guy's face, he took his goggles off for a little bit and now his eyelashes and eyebrows are frozen. So those 3 things are very important because the little bit of snow that falls every year doesn't melt, and it piles on top of itself in layers. So if you look at the picture, hopefully you guys can see that there are kind of stripes of light and dark in the photo. This is a scientist who's standing in a snow pit. So they dug about 6 feet into the ground, and this is what the snow looks like underneath. And each of those little stripes, or each layer, is actually an annual layer of snow. So it's 1 year's worth of snow. And scientists can actually learn a lot by studying those layers and by looking at what is trapped inside each of them. So you'll be hearing a little more about what scientists do with those layers a little later. But right now I'm going to hand the phone over to Tiffany, who is going to tell you a little bit about what we've seen and experienced so far in Antarctica.
Hi everyone, this is Tiffany. So one of my favorite things about Antarctica is that there is sunshine 24 hours a day. So that means the sun doesn't, we don't have a sunset, it doesn't go down, it's always bright and high in the sky. And it's still cold even though the sun is always out, so we are given what's called extreme cold weather gear, and we call it ECW for short. And it's basically a big red puffy coat that's really warm, and it has a hood with fur on it. We get some goggles, some snow pants, a couple pairs of gloves, some hats, some scarves, and some big insulated boots that we call bunny boots. We flew from New Zealand to Antarctica on a plane that is called a Hercules LC-130, and it's a big military plane with skis on the bottom. It's really cool on the inside because you can see all the little wires and gadgets that make the plane work. When we landed, we got off the plane. Yes.
Tiffany, we have a question for you from Shauna Ford's class at Curtis Elementary. They want to know, how long did it take you to get there?
How long did it take us to get here? How long did it take us to get here from our homes or from New Zealand?
How about both?
Let's see. So from our homes, it took us all a little bit different time. I came from Fairbanks, Alaska. So it took me probably about 50 or so hours total to get down to Antarctica. And from New Zealand to Antarctica, it took us, yes, 50 hours. It was a long, long flight. Several flights actually. But from New Zealand to Antarctica it took about 8 or so hours.
Thanks so much.
So when we,
and
of course.
sorry to interrupt, and we'll let you keep going.
No problem. Questions are more than welcome. So when we got off the plane, we walked over to what is called Ivan, the Terra bus, and it's a really big bus with huge wheels, as you can see in the picture there. And it drove us to our base. So it was about a half an hour or so ride. We went really slow because the road was really bumpy. It's all snow on the road. And the tires help the bus go in some of the softer snow. A couple of days ago, we have a bunch of trainings to do when we get down to Antarctica just to make sure that we're safe and everything when we're doing science in the field. One of the trainings we did was learning to drive a snowmobile. So we were taught how to check for things on the snowmobile to make sure that it's safe to ride, and then we actually learned how to drive it. So it was really fun. And after that, we went on a walk and we saw some Waddell seals. They were really cute. They were sitting on the ice, just sunbathing, kind of taking a nap, getting some stretches. They remind me a lot of a giant puppy dog. I love them. They're really cute. We also saw on this walk some really beautiful ice formations. Some of them were probably about as tall as a one-story building, like 12 feet or so high. Some of them were even taller than that. They were really pretty to look at. We also saw a volcano, which is called Mount Erebus. It's near our base here at McMurdo, and it's one of the 2 most active volcanoes in the world. It's really cool to see it from our base here. It's really neat. We also hope to see some penguins really soon. We probably won't see them until January when we come back from WAIS Divide, but we're hoping that they'll be here and we'll be able to see some and take some pictures. And yesterday, one of our tasks was to pack up all of our science equipment and get it ready to go on the plane. The plane will take it out to our camp for us, and these were packed in really, really, really big boxes. You could probably fit, I don't know, maybe 7 or 8 people in there. And yeah, we pack them up and they put them on the plane for us and send them out to camp. And I will pass the phone over to Rachel, and she will tell you about our camp.
Hi there, this is Rachel. This is my second time down in Antarctica, but it's the first time that I will be at this remote field camp that we call WAIS Divide. So it's going to be about a 3-hour plane ride from here. If you remember the slide that Yamini showed earlier about how big Antarctica is, and McMurdo was down at the bottom. Well, WAIS Divide's way over on the left side. WAIS stands for West Antarctic Ice Sheet, and that's such a long name that we just say WAIS because it's easier. And the West Antarctic Ice Sheet is the whole big, enormous sheet of ice covering West Antarctica, but we're going to one specific location, which is near the divide. So a divide is a boundary separating ice that's flowing in 2 different directions, sort of like a continental divide, if you know about those. So our camp is going to be 24 kilometers away from the ice divide on the West Antarctic Ice Sheet. And you can see it there on the left of the image. Okay, so what is it like at WAIS? This is the next slide. Basically, it's flat and white. Even though it's on the divide, the change in elevation is not very much, so it all looks very flat from the perspective of someone standing there. There's just white snow as far as the eye can see. What you're also seeing in this picture are the tents that we'll be sleeping in. This is called Tent City, and it's about a 5 or 10 minute walk from the building that we'll be working in. The West Antarctic Ice Sheet is cold. It's high. It's almost as high as Mount Washington. For those of you that live in the in the northeast. It's about what? It's like Denver. It's about as high as Denver, which you may know is the Mile High City. So it's colder and drier than it is even here in McMurdo. The average annual temperature there is 24 degrees below zero. And this is summertime because we're in the southern hemisphere. And so even now, at the height of summertime, the temperatures are still below zero by a few degrees. And the western Arctic ice sheet gets more snow than some parts of Antarctica. It gets about 1 meter of snow per year. But that compacts down because, you know, snow is light and fluffy, and as more snow gets piled on top of it, it compacts down into those thin annual layers that you saw on Yamini's picture of the snow pit. So when we're out there, the conditions will be pretty primitive. This is what's called a deep field camp. We'll sleep in those tents that I showed you earlier. There's a picture on this next slide of down in the right-hand corner of someone who's fixed theirs all up to be cute and homey. We are only going to be there for about 4 weeks, so we're probably not going to be prettying ours up as much, although I'd like to. And the other pictures you see on this slide are the galley. So the big yellow structure there you see on the lower left is what's called a Jamesway. And it's basically a long hemispherical tent with that little entrance structure, the blue door built at the end. And this one is the galley in the recreation building, and basically it's where the cook will make meals for us and we'll eat. Okay, and
hey Rachel, there's another question coming in. From Colette Weber and her students in Washington, and they are curious about how you get your food while you're there. Where does it come from?
Okay, so there are only going to be about 15 people out at this camp at WAIS Divide this year. But as long as we have more than 12, they actually assign someone to be a cook for us. And the cook and the food come in on a plane from McMurdo. Hopefully they're already there. They take the food in enormous crates like the one that Tiffany showed you we were packing yesterday. That contained our gear, but they take other ones in that contain food and toilet paper and paper towels and all of the things that you need for daily life, the same kinds of things that you would pick up from the grocery store. And the one thing that's missing there though, in the way of food is there's not a lot of fresh food. And that's true here in McMurdo at the main station as well. If you want fruit, a lot of it's canned fruit. Salad you don't get every day. And so we get really excited when we see fresh food. So going back to the slides, why did we choose to come to WAIS Divide? Why was this camp built here? Well, climate scientists like to look at the annual layers and ice sheets much as they like to look at the rings in trees. And you want an area where the annual layers are nice and even and flat and haven't been all munched up and folded over on one another. And so by picking an area with a flat bedrock topography and relatively little flow and unconstrained flow, so it's not as if the ice is being forced down a valley or forced out a glacier tongue. In this big flat open area that is WAIS Divide, you get nice even annual layers. And there's also a lot of ice here. There's a lot of snow cover. There's 3,465 meters of ice, so that's like 11,000 feet of ice. And that means that there's a climate record going back as far as 60,000 years. On the next slide, you'll see some ice coring and activities and ice cores. So what has happened at WAIS Divide over the past 5 years is that other teams have come down and have collected an enormous ice core that goes almost all the way down to the bottom, to the bedrock. So they have this 3,405 meter core of ice that they collected with this big round drill. It's sort of like an apple core, if you've ever seen anybody core an apple with one of those round things that pulls the core of it out intact. It's like that, only on a larger scale. And the ice core is about the same diameter as a CD or a DVD. And you see here in the upper left-hand corner a bit of the ice core sticking out of the drill. That's the bottom of the drill, and the triangular bits you see on there are actually the bits, the cutting part of the tool. And it goes around and around and cuts down slowly through the ice, and then regularly pulls up sections of ice. So what you see below here is a 1 meter section of ice. And that dark stripe that you see on there is something that some scientists are particularly interested in. That's a volcanic ash layer. So that layer came from when there was volcanic activity, either somewhere here on the Antarctic continent or possibly in some other part of the southern hemisphere. And the ash was carried by the wind over Antarctica and settled with the snow that year and created a dark layer. And over on the right you see a rack containing a whole bunch of 1 meter sections of core. And there seems to be a little mascot there that the drilling crew had with them. I don't know this little fellow's name, but we have a sort of a similar mascot with us this year, which if you follow our blog, you'll be introduced to. And now, so they've taken this big ice core out of the ground, and now there's an enormous hole. And I'm going to turn the talk over to Erin here, who's going to tell you what we're going to do with that hole.
Hello, everyone. This is Erin, and yeah, there's now this big hole in the ice that goes 2 miles down, 3,400 meters down to the bottom of the ice sheet. And you can see in this picture on the slide that says now there's a big hole that it kind of looks like a little white circle that's maybe about 1 foot in diameter, and that's just a little plastic covering. If you open that hole, if you open that cover, you can look down and imagine yourself looking all the way down to the bottom of the ice sheet. So it's pretty fun to try to yell down that hole and see if we can get an echo back. But we actually can't get an echo back because the hole is filled with a fluid, and it's a fluid that matches that doesn't freeze, and so we can keep the hole open even though, because the ice wants to close the hole, but with this fluid in there we can keep the hole open for a long time, and that gives us access to this deep ice, and so we can start asking more questions about the deep ice than we can get from the ice core itself. And that's exactly what we're going to do, because this big hole and all of the ice around it is actually moving. So these ice sheets, the snow falls on the top in the center of the ice sheet, but that snow has to go somewhere eventually because otherwise it would grow infinitely thick. And so what happens is when the ice sheet gets thick enough, it starts to flow. And like Rachel said, we're near the top. So you can see the red line where it says today on it. That's the borehole today. This is looking at the side now, like a cross section of our ice sheet. And we're going to be camped right at the very tippy top where the top of that red line meets the top of this bluish curve that is the top of our ice sheet. And very near us, there's ice flowing one direction, and then our ice that we're going to be camped on is flowing the other direction. And what we're going to do is measure the hole today where you see the straight line, and then we're going to come back in 2 years and measure it again. And that helps us understand a lot of details about how this deep ice flows, because that really helps us understand the whole climate history. It helps us understand how Antarctica works at all. So we'll be back here in 2 years, and you can follow us then as well. But that's one of the things that we can do. So this next slide shows our actual instrument that allows us to measure this movement. So the upper left picture there. Yep.
Erin, this is Sarah. If you don't mind me interrupting, there are 2 questions. Is that okay?
Yep.
So, Colette's group from, I believe, Washington, yeah, they want to know, how do you know how old the ice is? Do you have an easy way to explain that?
Yeah, so there's a couple of different ways that we know how old the ice is. The first way we know how old the ice is that those layers that you could see in the snow pit that we showed you twice in this, with the light and the darkness within the snow pit, that visible difference in summer versus winter snow actually persists a long ways. And so I believe in this particular core, you could visibly count the layers just by looking at the ice down to, I think, about 30,000 years. So yeah, are you drawing on the screen? I like that. Yeah, so that visible, you can actually see those visibly all the way down to about halfway deep in the ice and somewhere like 20 to 30,000 years. The other thing you can do is take a measurement of the conductivity. So that's looking at the little salts and dustiness that creates changes in the conductive properties of the ice. And if you measure that, you can continue counting down. And then we can do things like looking at volcanic events, like Rachel talked about. So if we know the date of a volcanic event, then we can say, hey, this is that volcanic event in this ice. And then there's a couple of other tricks that we can use as well to match up and make sure that we're getting the right, I wouldn't call them tricks really, but there's other data sets and methods of analysis. So we combine all of these together. We use maybe 6 or 7 different methods to try to get at the age of the ice and how that age compares to other ice cores around the world, and we also compare it to ocean cores in the bottom of the ocean. Yeah, so we use a bunch of different methods just to double check and triple check and make sure that we're getting it all right. And then in the end, if there's a section of core that we aren't quite sure the dates, say we have 2 volcanic events, but we don't really know what's happening in between because we can't see the layers. At that point, we actually try to estimate this deformation, the flow of the ice, which is what we're going out there to measure. But we can do some measurements and some calculations of what we expect the layers to be in between 2 known dated points. So there's a whole bunch of different ways that we go at getting this. That's a really good question. It's not as simple as it seems like it should be, but the top part of it certainly is. We can just visibly count the layers.
Thanks, Erin. And one more question that you might be getting to, but what is the most interesting detail that has been learned from investigating the ice core samples?
Well, this ice core is still very much being analyzed. All of the other scientists that are doing the chemistry analysis and the analysis of the dust and the samples of the ice themselves, all of that ice has been shipped back to all the different laboratories across the U.S. and they are pulling together their data sets and comparing them with each other. And we actually just had a meeting a couple of months ago where all of the scientists from all over the country that are working on this core came together to talk about what are some of the most interesting things. And so there's still going to be a lot coming out about this, but the one that I can think of that I think is quite interesting is that it's actually giving us a much better understanding of how changes in climate in the northern hemisphere propagate down to changes in climate in the southern hemisphere. So So if there's a huge change in climate that we think is initiated by something happening in the northern hemisphere that we see in Greenland ice cores, this is the first time we've been able to really see in detail how long it takes for that change in the Greenland area to be observable in the Antarctic. And according to that, it takes about 200 years for that change in climate to really propagate from the northern hemisphere to the southern hemisphere, which is not quite what everybody expected, and we're trying to understand better about the entire atmospheric ocean system that connects our whole climate. But that's one of the most interesting things that I've seen come out of this so far, but there's a whole bunch of interesting things coming out.
Thanks, Erin. That was
one more
perfect.
question there?
I think that was it. And then for folks that are listening in, we've got a couple more slides from the team, and then we'll be able to ask questions live if you have a microphone available. So think about that as we're coming through the last couple of slides. But I'll turn it right back to you, Erin.
Okay. So this instrument that we're going to send down is this long, skinny thing. It's about 6 feet long, 2 meters. And all it does is tell us what the geometry of the borehole is now. So it tells us about if it's tilted or not and whether it's a nice circular borehole. Oh, yeah, I think you need to go to the next slide. Yeah, there. And then in the lower right, so remember this hole is 2 miles long. So in order to send our little instrument that's only 2 meters long down this giant hole, we have to have 2 miles of cable to stick it on. And so that lower right picture shows a spool of cable that has 2 miles worth of steel cable on it. And that cable allows us to slowly lower our instrument down the hole. And it will take us about 36 hours to send our instrument from the top of the hole to the very bottom of the ice sheet and then bring it all the way back up to the top. The other thing that we're going to do as part of our project is connect this deformation with the tiny crystals in the ice, because they actually play a huge role in how that ice flows. And this is part of Rachel's expertise, and you can see this bottom right picture is Rachel in her laboratory back at Dartmouth College. And then the upper right picture is actually Tiffany in the laboratory at the University of Alaska. Rachel has a much fancier instrument that can do a lot more, but we can create these beautiful images like the left, which is just polarized light being shown through the ice that brings out the individual little tiny crystals. So we'll spend a lot of time looking at these little crystals and comparing that to our deformation measurements. But if you go to the last slide, in order to really get the best data on this project, we have to do our good luck dance before we lower our instrument into the borehole. And so the picture there is of another time when I did a measurement like this on the East Antarctic Ice Sheet. And this is my graduate student and my postdoctoral student. And they did the good luck dance before we lowered our instrument down into the borehole there. And if you do click on that image, and you might want to wait and do this afterwards, you can actually watch the good luck dance. And so I will be taking pictures of Rachel and Yamini and Tiffany doing the good luck dance this year. So that's all we have, and we would love to take questions. We have a bit of time for questions here, so we would love to hear some questions from everybody. And you can type them into the chat box or...
Perfect. Thanks everybody on the team for sharing all that work. That was great. So the way that this can work, folks that are in the audience that may have a question or two, it could be about WAIS Divide or what it's like in Antarctica or McMurdo or their travels so far or what you want to learn about while the team is out in the field. you can use your microphone to ask a question. So as a reminder, if you're interested, you would click the talk button to speak and click it again when you're done. And right above in the participant panel, there's a little hand icon, so you could raise your hand if you're ready to ask a question. We'll give folks some time to think about it, and there'll be a line of questions. And looks like Colette Weber and her class do have a question. So I'll turn it over to you. Press the talk button to ask your question, and then press it again when you're done.
Nice and loud.
How do you use how do you do survival skills?
Louder.
How do you do your survival skills?
So our question is, how do you learn your survival skills?
Yep.
Hi, this is Erin again. And yeah, in order to learn the survival skills, which are very important for living out there, is when you first get down here, we do a bunch of trainings. And actually Tiffany is leaving today to do her survival skill training. She's going to go out onto about 5 miles away from the base here, and she is going to dig herself a pit to sleep in maybe, or pitch a tent, and she'll cook her own food, and they'll talk about how to stay warm and what to do when a whiteout comes. They do a fun bucket challenge where if you put a white bucket on your head and you try to walk around, then you know what it's like to be lost in a whiteout. And so they have to go find somebody lost in a whiteout with buckets on their head, and it's quite amusing to watch. Or a whiteout, just in case you guys don't know, a whiteout is when there's enough of a storm that's blowing snow around that everything goes white and you can't see more than your hand in front of you. It's like being stuck in a really, really, really thick fog back home where you can't see anything.
Perfect.
Any other questions?
Yep. Looks like Deerfield Montessori Schools has a question, so I'll turn it over to them.
Hi. Our students had a question about the volcano. They're curious about how that works with Antarctica being so cold. When the volcano erupts, wouldn't it freeze or would it melt everything? They're wondering about the volcano.
That's a really great question, because yes, having volcanoes and ice together can often be quite beautiful interaction and complicated. So, volcanoes are warmed from heat deep in the earth that comes up to the surface. And yes, if it does erupt, there probably would be quite a bit of ice melted. But there's so much ice here that the heat of the volcano is not enough to melt it all away. So the volcano that's right up here, there actually is a liquid lava lake inside this volcano. So I have not had the privilege to go up there, but it's basically like a boiling cauldron of lava inside this volcano that you can see if you stand on the edge of the crater. But it's not, this volcano has not had a major eruption. So it's active, but it hasn't had a really major eruption in a while. So we know it's hot up there. There's not much ice that sticks at the top of the volcano, but the ice can still grow on the sides of the volcano. So it's sort of a balance between the coldness of the ice and the environment and the warmth of the volcano. And they're always kind of feeding back on each other. And if the volcano did heat up, then yeah, we would get a lot more melted ice. There would be a lot more exposed land up on the top of the volcano.
Thanks so much. I'm going to put a link out here of a PolarTREC expedition that learned a lot about the volcano, so folks can have that if they're curious about more questions about the volcano. And now looks like Shauna Ford and the Curtis Elementary group have a question. Go right ahead.
Hi, my name is Caitlin. How long do you keep the core samples?
I'm sorry, I didn't quite get that. How long did it take to get the core samples?
How long do you keep them?
Can you repeat it? How long do we keep them? Yeah, so in Denver, Colorado, there's a gigantic warehouse that's called the National Ice Core Laboratory. And if you're ever in the Denver area, they love having visitors. You just need to call them up and say, we want to come visit. They love school groups. But they keep these cores for as long as we have space for in the warehouse. So there are cores within this cold. The warehouse has a temperature of -35, and we can keep these cores for 30, 40 years. We actually have some ice cores there from the 60s and 70s and 80s. And as long as valid, scientifically useful, then we do everything possible to try to keep them for as long as possible.
Great, thanks. Looks like Colette's group has another question. Go ahead, Colette.
Hi, Erin just handed the phone to me. This is Rachel. Sorry, can you repeat your question? What is your question?
All right, Colette's group, I see that your microphone is on, so go ahead and talk if you can. Otherwise, we're not hearing you. Right, so Colette Weber's group, your question is, why are the boots called bunny boots? Sorry that your mic isn't working.
Why are the boots called bunny boots? Do you know the answer? We actually don't know the answer to this. I suppose because they're big and white and they look like a snowshoe hare's back feet. They're incredibly warm, and one of the reasons that they're so warm is that there's about 2 or 3 inches of padding and insulation under your feet. When you're standing around in the ice and the snow, what really makes your feet the coldest is losing heat through the bottoms of them to the ground. And so all of the super, super warm boots for this kind of work have really, really thick soles underneath. So we all get to be a couple of inches taller than we normally are. And by the way, they can be pretty hard to walk in too, because we are kind of going clump, 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 and tripping over our own feet everywhere we go. It's hard to do a dance in them. So people that can do a happy dance in them are especially valued on these expeditions.
Cute. All right, we do have time for a few more questions. And so Shauna Ford's group with Curtis Elementary, go ahead.
Hello, my name is Jude, and what happens if Antarctica melts?
Oops, all I heard was what happens in Antarctica about, and then it sounds like you cut out.
What happens when Antarctica's ice melts?
What happens when Antarctica melts? Is that your question?
Yes.
Okay. Well, hopefully Antarctica won't melt completely anytime soon. As you know, Antarctica is a continent, so there is ground under the ice. So it wouldn't, if it melted, it wouldn't entirely go away. There would be a continent with open ground like back home in the United States. But all of that ice and snow that's sitting on the continent, those ice sheets would have to go somewhere, and where they would go is into the ocean, and that would make the sea level rise. So if Antarctica melted, or large portions of it did, like the West Antarctic Ice Sheet, the sea level all over the world would rise by several feet, and low-lying areas, for instance, in Florida and along the coastline, would become flooded.
Okay, so Deerfield, go ahead if you have a question.
Hi, our question is, what inspired you to do this scientific study in Antarctica?
Oh, hold on, I'm going to tell my whole group that question because I think everybody probably has a different answer. The question is, what inspired us to do this work in Antarctica? I think, speaking broadly, it's a combination of we love science and we also love being in wild, beautiful places. You have anything to add to that, Erin? Erin is the most experienced of us here, and she has been down here 11 times. So I'll hand the phone to her and she can add to that.
Hi everyone, this is Erin again. And yeah, I actually went to school to study mechanical engineering, and Rachel also did engineering as an undergraduate. But then I realized that I wanted to take my engineering skills and apply them to a problem that just hit me better in my heart. And so I used my engineering skills to connect my love of mountaineering in the mountains and my interest in solving problems like global climate change and my sense of adventure. And so I combined all of that together and realized that this world of the Antarctic and paleoclimate and just understanding all of the icy covered areas of our planet just really was the way that I wanted to use my engineering background.
Great answers, thanks. Looks like Shauna Ford's group was asking about the doll, Goldilocks. What's the story on that?
So Goldilocks is she's an inventor. She's a girl inventor, and she was invented by some women who are engineers from Stanford. And they wanted to make a doll that shows that there are women and there are girls who are really great engineers and inventors. And so all of the Goldilocks toys come with a little kit where you can build something. Ours has a zip line. So we have Goldilocks here with us. She's our 5th team member, and she's going to be coming everywhere with us and posing in our pictures. We also have a zip line set up across our office right now, so sometimes she just likes to zip across the office. And it's just for fun, and it's just to show people some of the different things that we're doing, and also just to encourage everyone, whether you're a girl, whether you're a boy, it doesn't matter, but science is really cool and really fun, and you guys should try it and see how you like it. And we hope that a lot of you guys will grow up and someday be in Antarctica and be writing blogs that we can read so we can keep learning more. Does that answer your question?
Sounds good. And I am looking real quick to see if we've even met Goldilocks in your journals. I know she's made an appearance on Facebook, but it would be great to see her in your photos. I don't think I see her yet.
That's true. Goldilocks will definitely be making an appearance in our journals soon.
Awesome. All right, I think we have time for one more question. Looks like Deerfield Montessori does have a question.
Hi, our last question is about where and how do you get your power in such a remote place?
Ooh, where and how do we get our power?
Hi, this is Erin again, and I understand the question is about where we get our power out at camp. And this camp, most of the camps that I normally go to are small camps with like 6 to 8 people. And when I'm at these small camps, we use solar panels as much as we can, and then we have a little generator for a backup. But at this big camp, they actually have some pretty big generators that will run off of the jet fuel that is used for the airplanes. And so they'll have a couple of big generators. That's in terms of providing enough power for up to 30, 40. This camp in past years has maxed out at 80 people. And so the facilities are set up for providing power for that many people, which is a bit hard to do with solar panels at this point still. So yeah, we have big generators out there to provide that for us.
Awesome. Well, ladies, so much for this event. It's been great. I know that Shauna Ford, your group wanted to let the team know why you were participating. I believe Janet was mentioning that earlier. Can I turn the microphone over to you, Shauna? Go ahead, Shauna.
Yeah, my name is April Lepla, and I teach 6th grade here at Curtis. We had an opportunity. My father went to Antarctica just as a vacation with a dive group, and so he was able to Skype with my class and kind of give them information from a visitor standpoint, just about the weather and the geography and climate and things like that. So with that, my students kind of gained a little bit of knowledge and wanted to know a little bit more, and so we told Ms. Ford, and she found it from a scientific point of view, and that's why we're excited to talk to you about it.
Oh, that's wonderful. It's great that he had that opportunity. He probably was at a camp that we share a little bit of science with. I haven't been over there, but there is a camp where both the tourists and the scientists work together or stay at the same camp and share facilities a little bit.
Thanks. Perfect.
But that's great.
Well, we are going to wrap up the event. Let's say thanks to the team, and PolarTREC will get the event archived shortly, so it'll be available on our website, and we'll send the link to all of the participants. And remember, there are upcoming events. Even tomorrow, we have an event just about the same time, 1 hour earlier, with Lucy Coleman, who was out in the dry valleys that were mentioned earlier. And she's back at McMurdo, so she has an event. And remember, there's lots of ways to connect with the Velvet Ice Expedition, especially on the page, the PolarTREC page, but also through Facebook and Twitter. But thanks so much to everybody. And at this point, I'm going to turn off the